మ్యూట్లో ఉంది.
Acres. It has sophisticated conference halls, lecture halls, advanced infrastructure, and well-established laboratories. It is providing 24/7 security and RO water facility. The campus is providing separate hostels for boys and girls with good canteen and guest house. There is centrally located spacious library with provincial publications of journals, magazines, 20 editions of daily newspapers, and all the academic books of different branches with a collection of 30,000 plus volumes. The IEEE 3000 standard collection for industrial and commercial power systems. The digital library is facilitated with onto the digital like NPTEL and also having national and international journals. The VCTN has been established in 2008 with world-class technology and running successful under the supervision of Dr. B. Ramana, the dynamic and hardworking principal. The courses offered in BTech are Civil Engineering, Electrical and Electronics Engineering, Mechanical Engineering, Electronics and Communication Engineering, Computer Science Engineering, Agricultural Engineering. In MTech, the courses are offered for Computer Science Engineering, Embedded Systems, Machine Design, Power Electronics, Electrical Drives and Structural Engineering, MBA. Vikas Group of Institutions was established in 2010 with corporate infrastructure. It has been running under the supervision of Dr. B. Ram Mohan Rao, Principal. The courses offered in BTech are Civil Engineering, Electrical and Electronics Engineering, Mechanical Engineering, Electronics and Communication Engineering, Computer Science Engineering, Agricultural Engineering. And courses offered for MTech are Computer Science Engineering, Digital Electronics and Communication System, VLSI Design, Electrical Power Systems, Thermal Engineering, Structural Engineering, MBA. Our civil
Good afternoon, everyone. I am Pottam Srinivasrao, HOD.
Good afternoon to all the participants. Welcome to our program, a webinar on career opportunities and recent developments in non-destructive testing. This program is initiated to reach all the faculty and students. Firstly, I would like to thank our department HOD, Mr. Pottam Srinivasrao garu, for encouraging, supportive, for conducting useful programs. I would like to thank management and principals for their support. I would like to thank the program convener Mr. MVU Bhaskarrao garu and co-convener Mr. T. Mastanaya garu and all the faculty members for their support. Before going to start our session, I would like to introduce the institute VIDAL NDT. VIDAL NDT is one among the leading and top training institutes in this region, floated by qualified professionals. It offers broad range of training certification programs to mold students with vigorous training methods employing the most effective resources. VIDAL NDT have expert faculty and magnificent infrastructure. VIDAL NDT main aim is to convert engineer to professional engineer. Number of students nationally and internationally. Conducted placement drives training programs for engineering and diploma students, MOUs with core industrial units and many reputed colleges, and received many awards and appreciation letters. VIDAL NDT offers PG programs, quality management programs, design programs, fire and safety, and many more.
సార్ నేను ప్రజెంట్ చేశాను. So in this class, at the conclusion, we are going to have answers. Sir, a warm good afternoon to one and all, to all the faculty, students, and other all respective people who are live to this webinar of career and objectives and opportunities of NDT, which is non-destructive testing. And after welcoming, I am here to say some key points and important things on which we are going to discuss today, and have some conclusions of these particular doubts, and all regular doubts for all the students and all the stuff. Why is NDT and what is NDT? Many people ask what is the useful of NDT, and there are many courses, but why only NDT? So by the end of the session, we are going to answer all these queries and doubts and any other things for a person who is going to question why only NDT. So here I have some questions on the screen, like what is NDT? So NDT is an type of testing in which we are going to test the component by not physically breaking or not physically applying any load, and inspecting or detecting whether there is any flaw or a defect in a component. So, and secondly, how to be an NDT technician? It's not possible for all the persons to be an NDT technician, and there are also levels like level 1, level 2, and level 3 in NDT in technician levels. So that first of all, we need to know our eligibility, and nextly, what are the certifications in NDT? There are many certifications in NDT, as we discussed before, like level 1, level 2, and level 3. Many more certifications, not only in NDT. After being an NDT technician, there are also many other streams like welding inspector, audit inspector, and paint inspector, boiler inspector, many other streams after doing NDT certifications. And who is eligible to do this course? Any graduate or diploma candidate can do this course. Not only freshers or not only currently running passed out students is eligible for this particular type of course. Any person, he might be passed out before 2 years, 3 years, 10 years, any person who is interested to mold his career upon NDT, anyone can be do this particular certification course. No limitation of age as well. And coming to the placements and job opportunities, NDT is a type of test in which a mechanical objects or mechanical tools have been involved. No one can say a mechanical tool or mechanical object is going to end at this particular time. So for example, I can say a car manufacturing company. A car manufacturing company, before getting into market, we need to test or we need to check the quality of the car, and to check the quality of the car, we need to do a type of testing called NDT testing. And secondly, before launching an aeroplane has to be tested. So before launching the aeroplane, the type of test which is going to be undertaken by aerospace industries is called NDT. So we can't say a car or an aerospace industry is going to be ended at this particular point of time. So until and unless they are going to be ended, we have the opportunities for that long time, so that we will be having opportunities and number of job opportunities and career objectives, and also multiple type of options to select in this particular point of NDT career. And coming to our technical part, before getting into NDT, I need to have some very I need to give some very clear cut explanation of what is the difference between destructive testing and non-destructive testing. Here, the destructive testing is nothing but an inspection of material and its properties by applying loads until the material gets physically failure. In the sense, if you have a shaft, we are going to apply some particular type of load upon the shaft, and we are going to make it failure until it gets break or been cracked or been changed physically. So what are the type of testings that have been involved in destruction testing is, I have some listed some points here. You can see like tensile test and hardness test, sharpie test, shear strength, compression test, torsion test, bend test. All these type of tests are called destruction testing. So you can see the image, like the arrow marks in the image is going to indicate the application of load in that particular direction onto the component. Once after applying the load upon the component, definitely it's going to change its physical appearance, and the change of physical appearance is going to mention or rationalize the strength of the component. So what are the disadvantages that we can see or we can discuss about destruction testing is the change in physical appearance, which cannot be used for further purposes. If I have a shaft of 10 centimeters, I am going to induce an test called destruction testing for tension or compression on that particular type of shaft. I can't use it for any further type of operations or further type of processes. Why? Because it has been already changed its physical dimensions, so I can't use this. And the third one is no flaws can be detected in these particular destruction testing. The flaws cannot be inspected or detected in destruction testing. The only purpose of destruction testing is to find the material property and material strength only. We can't find any single point of defect or any chance of trace of defects. And coming to destruction testing, here there is a small definition which can be able to understand for everyone, like any method for examining a object or a material or a job or a workpiece or a test specimen, anything, in any manner which will not impair its future usefulness. Like why I mentioned many methods is, in NDT also there is no, NDT is not just a single method, there are number of methods involved in NDT also. So that's why I mentioned many methods or any method. So any method that you are going to use in NDT for inspecting a material, definitely it's not going to stop its future usefulness. Definitely very soon after inspecting a component by NDT, you can also use for its future purposes. That's why I mentioned a note, simply testing without destruction. We are going to test a component without destructing its physical mechanical properties of a component. And what is the result that we are going to get by doing NDT is, we can see whether there is any flaw or air gap or defect in a particular component. If there is a flaw in a particular component, we can't say or we can't conclude that particular type of component is going to be accepted or is safe for future purposes. So before getting into market, any product or any material is going to be tested on its quality wise, and the test carried for quality inspection is called NDT inspection. And getting into detailed why NDT and where we are going to use this NDT. Firstly, we are going to detect the internal and external flaws of the component. internal and external, I specially mentioned, we can also find the internal components. Like if I have a 10 centimeter of a component, I can see whether there is any surface defects by our naked eye, but we can't see the internal defects through our normal human eye. But by using these type of NDT methods, we can also find both the internal and external flaws that are being present in the component. And secondly, measuring the geometric characteristics. So measurement is nothing but, if we have a scale or we have a tape, we can simply measure any component. But there are some things that had to be measured by only using NDT. Why? Because if there is some internally dimensions which is very much important, like the centimeter or the breadth or the width of an aeroplane or a turbine blade, we can't see the length or a thickness of the turbine blade by using measuring scale or a normal centimeter scale. We need to have other type of measuring devices like NDT. In NDT there is a particular test called ultrasonic test, so that by using this ultrasonic test we can also check the thickness of the any component. Okay. And nextly, we are going to determine the material structure or composition. And material structure, like we have already discussed, in ultrasonic testing we are going to know what type of material we are going to be testing, and what is the percentage of composition, what is the percentage of one material to another material that has been variated. We can conclude by using NDT type of testings. And nextly, measure some of material properties. Material properties is nothing but the structure, and by knowing the structure and composition of material, definitely we will be knowing the material property. But one thing I can say is, we are not going to check any physical properties or mechanical properties. We are just going to find the structure and composition, not strength and forces. Okay. And hereby, for the next slide, what are the different applications, various applications of NDT is, we can use NDT in aerospace industries, aircraft industries, automobile, forging, casting, chemical and petroleum industries, and constructional industries, electronics and food processing, marine, material joining, security purposes, metals and non-metals even, nuclear, ordnance, transportation and utilities. Hope so all these points or key points are familiar. The 3 points which I feel which is non-familiar is construction and ordnance and utilities and food processing even though. So in construction, as I discussed in previous session or previous minute, I have mentioned in mechanical industries also, the construction field is also having much more applications and much more advantages of using NDT. So it's not only focused on mechanical stream, it's also focused on constructional stream and also medical applications as well. Food processing, in the sense, we are not going to inspect the food here. Okay, we are going to inspect the machinery or the type of mechanical tools being made the process of food processing. And ordnance is nothing but like military tankers, etc., etc., comes under ordinances. And utilities, you can say anything. In any industries, it might be gas, water, or anything, any component or any part individually, we can say it as utilities, like pipe joining, L joints and T joints, anything. These all things comes under utilities. So we can also inspect these type of component, individual component, by using NDT. And what are the basic materials, or what are the basic NDT methods that has been used so long and so widely is, there are 6 NDT methods. So what are the 6 methods? Before getting into 6 methods, I need to explain why it has been differentiated or why it has been categorized. So actually there are 14 type of NDT methods to do an inspection of a single component. but we are going to discuss about only 6 in today's session. Why? Because only these 6 type of NDT methods is being familiar more than 10 years or more than many years in mechanical industries, and only these 6 methods are much more easier as well as much more useful, both in financial side and also in result side as well. Very much low cost and also very much high effect by using these 6 types of NDT methods. And as the categories in NDT methods has been categorized into 2 different types of categories. First one is conventional testing and the second one is non-conventional testing. The non-conventional testing is nothing but an quality assurance check or quality, the process has been followed after the quality inspection. So not all industries need these type of testing called non-conventional testing, like for example laser treatments and resonance testings and photographic view testings, etc., etc., comes under non-conventional type of testings. The name itself indicates, like laser testing is not that much easy and also that much safe to undergo these type of testings, and also it is more commercialized and more cost, so that we are going to discuss about conventional testing. The conventional testing has 6 methods which are very much familiar and very easy and also applicable in every industry, not only in India. It is the type of testing which is going to use in worldwide industries, not only particular in India. You can see these type of methodologies in America and German countries as well. The machine has been first invented in Germany, so even the German companies also prior these 6 types of NDT testings to do inspection test of any particular material. So coming to the types of NDT testing, the first one is radiographic testing, in which we are going to inspect the material by using radiations. So a test undergone by using of radiation is called radiographic test. And the second one is magnetic particle testing. Here I mention we are not going to do inspection on magnets. Also we are not going to do inspection by using magnets. Here we are going to inspect regular mechanical compound only, but by using the magnetic field we are just going to induce the magnetic field lines into the compound and check whether there is any disturbances or defects in a particular component or not. That is called magnetic particle inspection. And ultrasonic inspection, which is very much useful for an career development for any particular individual who choose NDT as their professional career. Okay, in these type of testings we are going to use some type of test called ultrasonic sounds, in which we are going to find the resonance and the disturbance medium, which indicates the length of the defect and also the distance of the defect from the surface level. Here simply concluding, ultrasonic testing is nothing but a type of testing in which the result is going to be concluded or the result is going to be shown by using ultrasonic sounds. And the fourth one is liquid penetrant testing. The liquid penetrant testing is also one of the very much familiar and also I can say it is most simplest method than any other in NDT. The liquid penetrant testing is nothing but we are going to use some type of liquids like called penetrants on the material surfaces, and we can identify some defects that are being present on the surface which cannot be seen through our normal human eye. And the third one is eddy current test. Eddy current test is not being very much familiar, and so the next one is visual testing. Anything that you can see through your normal eyes is called visual inspection. If you are going to see an bike, you can see the color of the bike, you can see the height of the bike, and you can see the width and breadth of the bike. It is also one type of visible inspection only. Anything that you can see through your eyes is called visible inspection. But the thing is, you are not going to make a record of what you are going to see. But here, anything that you are going to see, you are making a record in industry, then it is called visual inspection. It is one of the most important type of testing. Why I mentioned one of the most important is all type of NDT methods are directly and indirectly linked up with visual inspection. Why? Because if I found any defect in a component, I need to know what is the length of the defect, what is the type of the defect, and how much effect it has on the component. Okay, so in order to know these type of lengths and other dimensional things of defect, we need to inspect through visible testing. Okay, then only we will have a proper record of that particular defect, and then we can conclude whether it is accepted or rejected. Okay, and here we will go for individual type of testings. The first and foremost type of testing is radiographic testing. Here, as I said earlier, this is a type of test in which radiations has been used to inspect a component. Coming to the points, key points that you have been seeing, the first one is RT involves the use of penetrating X-rays or gamma rays or radiations as sources to examine parts and products for imperfections. Here, as I said earlier, we are going to use X-rays and gamma rays as a source to examine the part. Why only X-rays and why only gamma rays is, as the human race has been started, we have number of radiations, like even the sunlight is also one type of radiation called ultraviolet radiations. And the first man-made rays was sound waves, which is called radio waves. We can hear in FMs, and the TVs uses microwaves, and the telephones or mobile phones uses infrared radiation. Of course, there are many types of radiations, even alpha, beta are also called radiations, but we only use X-rays and gamma rays to inspect a material in NDT. By so, why? Because only X-rays and gamma rays will have a capacity to induce or to penetrate into a component. Then only we can find whether there is any defect or not inside the component. So no other radiations like radio waves or microwaves, no other radiations will be having the capacity to get into the component. So only X-rays and gamma radiations will get penetrated into the component and trace what are the gaps and what are the structures inside internally into the component, and make a note, so that note will determine whether the component is efficient or non acceptable component. The second one is radiation is directed through a part and onto a film. So here on the screen you can see some red color rays, or you can say it as beams, beams falling upon a circular object, then upon a yellow color screen. This yellow color screen is called film, especially I mentioned X-ray films, and these red color beams are called radiations. So when a radiation is made directed upon an component, then after to an X-ray film, this X-ray film notes the dimensions and the material characteristics and the gaps as well, and the volumetric dimensions of this particular material, in which we can see whether there is any defect or not. Then when the film is developed, a shadow graph is obtained that shows the internal soundness of a part. As I said earlier, the film is going to show whether there is any defect or not in the particular type of component. I will make it very clear in the next slide. And the last point in this is possible imperfections shows up a density changes in the film in much the same manner as the medical radiograph can show broken bones. As we know, everyone when they get fractured medically, they will take some X-rays to know or to have an idea how much breakage it is, or how serious the breakage is, how major the fracture is. So you can in an X-ray screen you can see a black screen and a white colored bone, and if the white colored bone have any cracks upon it, you are going to conclude there is a fracture in your hand or in your particular individual bone. In the same way, the white colored bone is going to be a material in radiographic testing, and any black color indications upon a white color is going to indicate a defect. See here, here it is very clear. This is the source through which even X-rays or gamma rays is going to fall upon an object. Here I have an rectangular type of object here, and this is also called test specimen, job or mechanical component, whatever it is in your terminology. The radiations has been directed upon to the test component, and here there is an film called X-ray film, and X-ray film is here protected through a LED screen and cassette. Why? Why so? Even in cameras we use negative to capture the image which we want, isn't it? So this negative is not going to expose in daylight or sunlight. Why? If it is being exposed to any light temperature or atmospheric conditions, definitely the reel or the negative is going to be spoiled. In the same way, our X-ray film will also get spoiled once it gets exposed to sunlight or any atmospheric radiations. So we need to protect. The only protection that we can give for those X-ray film is through LED screens and cassettes. The LED screens can hold or reflect any type of atmospheric radiations or sunlight radiations making fall upon the film, so that we can say no radiations will affect the film. And why cassette? We can stop only the radiations by using LED screens, but not the light, or but not any sort of in Telugu we can say it as velutur. uh, and cassette is going to hide or cover the complete film by making it. In such a case we can conclude that no other radiations or no other atmospheric conditions can affect the film. This is the particular type of protections we are going to apply for the film. So here by applying the source upon the component and placing the film behind the component, this film is going to make record of a particular test specimen. And what is the image of the test specimen? The thing is like, when we take an image in an camera, not recently using cameras, before cameras, image is being taken in a negative, and after developing the image we will have a proper photo, isn't it? In the same way, the negative is going to hold the image of test specimen here. Okay, in that particular image we will be having whether there is any defects or not. See here, in a rectangular block we have a small circular hole which indicates there is a presence of defect or a flaw in the particular block. When you develop a film, the developed film will be white in color, that indicates the rectangular specimen or an object, and these black color indications, the cursor is moving here right now, and these particular black color indications is going to make conclude that there is presence of defect in this particular component. Okay, if there is any line here as well, then we can say there is a defect in this particular point or in this particular area in the component. Okay, and we can I'm not saying very soon after inducing or directing the X-ray radiations upon the film we can get the results. There are some particular process to be carried out after applying radiations. So first of all, if this is an this is a component, and my hand is in film, I need to induce the radiations upon the component, and these radiations will pass through the component and fall on my hand, and my hand will save all those results of the mobile phone. And now, to make sure that we can see these particular phone specifications on film, we need to undergo a process called film development process, which has been involved 5 different steps. The first one is developing, stopping, fixing, washing and drying. After doing these 5 processes, we can see the image that you are seeing on the screen right now. After being film development process, the white colored image will turn into developed film, in which you can notice all the types of defects that are being existing in the component. If there is no component, there will be no black color indications upon the film actually. Okay, hope you are clear. And one more thing I need to conclude is, of course, radiation testing is very much harmful to a human body, but no industry is going to ask a man to die to do an inspection of this particular component. Definitely, an industry gets legal authentication or authorization of these types of testings, and make sure the person who undergoes these type of testing is in safe, precautive and preventive of these types of radiations. There are only 3 basic factors that we need to note to as in precautions of these RT is: make distance from inspection area to the human body. Like, if this is here, this is the source point, right? We need to have maximum distance away from this point. Very soon after switching off the radiation, then we can go and adjust the further things. Okay, and it's not as simple as I said now. Actually, it is very much tough, and we need to have some particular type of courses to do RT test upon the material effectively. Okay, and what type of testing in which it is varied from other testings is the type of defects that we can inspect in radiographic testings is hidden defects and also volumetric defects. Why I'm saying hidden is the internal flaws, the internal component defects cannot be seen or cannot be visible through our normal eyes. Hence, it is hidden defects. And what is volumetric defects is we can see the particular shape and size of the defects of the component. That's why I'm mentioning volumetric defects. The type of defects that we can see or we can note by using radiographic inspection is hidden defects, and also volumetric defects can be noted. And what is the type of results that we can get or we can attain in radiographic inspection is permanent results. For an example, even one of you or your neighbors may inspect or take x-rays, isn't it? And x-rays results will be last for many years. It won't happen anything. The results will stay as it is in an x-ray film. Why? Because it is one time films. As you can say, you can compare it as a disk. If I'm going to give one input to the disk, it will be permanent, it cannot be erased from the disk. In the same way, if I'm going to induce a particular component result upon the film, it will be lasting for many years, more than 10 years also. It will not be destroyed or it will not be disturbed. Okay, and range of testing is 20 sorry 200 mm. What is the sense? From 5 mm to 200 mm, we can test any component by using radiographic testing. There is no limitations like I need to have only surface clean or smooth surface. There is no such type of conditions in radiographic testing. You can do this type of testing in any surface, whether it might be smooth surface or a rough surface or a hard surface, any type of surface like cylindrical surface or a circular surface. Any type of surface can undergo an inspection called radiographic inspection. Okay, and one more thing, the type of radiations if it is x-rays, it is not mentioned. The same x-rays are being used in medical applications also. There are difference from x-rays being used in medical applications and industrial applications. To make it clear, Actually, the radiations has been divided into two types in particular X-rays. They are soft X-rays and hard X-rays. The soft X-rays is being used in medical applications, and the hard X-rays is being used in industrial applications. What is the margin of hard and soft X-rays is the radiation has been measured in 5 ME mega electrovolts. If it is less than 5 MeV, then it is considered as soft X-rays, which can be used in medical applications, and if it crosses 5 MeV, then it is called hard X-rays, and it is used in industrial applications. So why we are not going to use hard type of X-rays in medical applications is, if the radiation effect is higher, then the body tissues will be easily affected through those type of radiations. That's why no medical applications or no medical devices will be using hard X-rays. The hard X-rays is only meant or only used in industries. Why? Because the material will not have life, and they will not get affected also, since we are going to use hard type of X-rays in medical applications. And the sources or the resources of generating those X-rays of those radiations is, if you want, you have to induce X-rays, you need to have a source called tungsten or silver or molybdenum. These three materials act as a source of anode to produce the X-rays. And when it comes to gamma rays, gradually there are many type of radioisotopes which generates the radiations, but especially I mentioned iridium 192 and cobalt 60. Why? Because many industries use iridium 192 as an radioisotope to generate gamma rays for particular type of radiographic inspections in NDT. Okay, clear? And next type of inspection is magnetic particle inspection. Here, as I said earlier, we are not going to inspect a magnet, and also I can say we are not going to inspect by using magnet, just we are going to inspect a component which can be magnetized, called ferromagnetic material. Here I have mentioned in point. Magnetic particle testing, or MT, is done by inducing a magnetic field in an ferromagnetic material and dusting the surface with iron powder. Okay, so here this is the ferromagnetic material. What is ferromagnetic? In the sense, again, the material has been divided into three major types, and they are dia, para, and ferro. Dia, the example for dia is gold and silver, which cannot attracted for magnet. And para is aluminum, which can partially attracted to magnet, and ferro, which can easily get attracted, and the impact of attraction will also be heavy. For example, we can consider steel and cast iron or iron. Okay, so we can do inspections of only cast iron, steel components, and iron components in magnetic particle testing. Not all type of components can be inspected in magnetic particle testing, and these particular components are technically denoted as ferromagnetic materials. Okay, no need to be worried, or no need to be tensed. Why? Because all kind of mechanical industries will prefer only iron or cast iron or steel type of components due to its high strength, or due to its flexibilities of making a product. Okay, and here in the second image you can see an component having a crack here. Here there is an N and S as well. This side there is an S. Okay, the magnetic fields passes from S to N, and if there is any presence of a crack in a particular component, the lines cannot be traveled in the same path. Like you can see in down side of the part, there is no cracks here, so the field lines are traveling in a parallel line or in an horizontal line, but when in the case of a presence of crack, they cannot pass in the same horizontal line. They have some deviations on magnetic field lines, and these type of deviations is going to make sure that you can see the defects in that particular shape. So the surface and near surface imperfections will distort the magnetic field and concentrate the iron powder near such discontinuities, these indicating their presence. See, um, uh, when a component is having a break upon a breakage or a crack upon a surface, the magnetic lines are passing, and at the presence of breakage, the lines will just leak and deviate their path and move on to the same field lines. But these deviations is going to hold some type of powder called iron powder, which is going to be applied upon the entire component. I will show it in the next slide. Here there is an component with N and S poles, and there is an equipment with N and S poles even, called magnetic yoke. These the use of these magnetic yoke is to induce the magnetic lines upon the component. So after inducing the magnetic lines, the leakages will be done, but we can't see the leakages by our eyes, isn't it? So we need to note where the leakages have been happened, or at least we need to know whether there is any leakages happening or not. So in order to make sure whether there is leakages or there is no leakages, we need to control whether the magnetic field is being induced into the component. So I'm going to apply iron powder upon the entire surfaces of the component. The inspection area, even if I am going to apply the powder and to the entire surface, the inspection area will be considered as only the area in between north pole to south pole of these yoke, not the components north pole and south pole, the south pole of yoke here, from north pole to south pole. Only this area is going to call as inspection area. The equipment has capability to inspect the defects at only this area. So have been applied magnetic powder upon this area, and after removing the yoke, we can see the particle has been remained at the particular surface or particular part of the component. Why? Because only that particle, or behind that particles, there is an presence of defect, and rest of the surface there is no defects and has been very clear cut image. So the only this area there is a defect, and as the indication, or to feel the presence of the defect at that particular area, the particle has been stopped upon the surfaces. Is it clear? uh, I will I will also explain it in Telugu, no issues. Yep. See here, మనం ఒక కాంపోనెంట్ని ఎలా ప్లేస్ చేసుకొని దానిపైన కనుక ఒక మ్యాగ్నెటిక్ యోక్ని పెట్టినట్లయితే దాంట్లో ఆ మ్యాగ్నెటిక్ ఫీలింగ్స్ అనేది ఆ కాంపోనెంట్లో వెళ్తూ ఉంటుంది అనమాట. ఇక్కడ మనం ఇమేజ్లో చూసినట్టు ఇప్పుడు నార్త్ పోల్ అండ్ సౌత్ పోల్ తీసుకొని, సో దట్ ఆ నార్త్ పోల్ అండ్ సౌత్ పోల్ మధ్యలో, ఈ యోక్ యొక్క నార్త్ పోల్ అండ్ సౌత్ పోల్ మధ్యలో ఉన్న ఏరియాలో ఉన్న డిఫెక్ట్స్ మాత్రమే మనం ఫైండ్ అవుట్ చేయగలం అనమాట. అండ్ ఫైండ్ అవుట్ చేయాలంటే మ్యాగ్నెటిక్ ఫీలింగ్స్ ఎక్కడైతే లీక్ అవుతుందో, అండ్ ఇక్కడ చూసినట్లు ఎక్కడైతే మ్యాగ్నెటిక్ ఫీల్డ్స్ అనేది లీక్ అవుతుందో అక్కడ మ్యాగ్నెటిజం అంటేనే అట్రాక్షన్, కాబట్టి ఆ మ్యాగ్నెటిక్ ఫీల్డ్ లైన్స్ అనేది మనం ఏదైతే పౌడర్ని అప్లై చేసామో ఆ పౌడర్ని డిఫెక్ట్స్ ఉన్న చోట అలాగే అతికించి పెట్టుకుని ఉంటుంది అనమాట. సో దట్ యోక్ తీసిన తర్వాత కూడా ఆ ఫీల్డ్ లైన్స్ దగ్గర, ఆ లీకేజ్ జరిగిన ఫీల్డ్ లైన్స్ దగ్గర ఉన్న ఈ పార్టికల్స్ అనేది ఏదైతే ఉన్నాయో అవి వెళ్ళకుండా అలాగే కాంపోనెంట్ మీద రెస్ట్ అయి ఉండడం వల్ల ఆ పర్టికులర్ కాంపోనెంట్ దగ్గరే డిఫెక్ట్స్ ఉందని మనం నిర్ధారించుకోవచ్చు అనమాట. సో దట్ నాట్ ఓన్లీ ఒక పాయింట్లోకి కాదు, డిఫెక్ట్ అనేది ఏ షేప్లో అయితే ఉంటుందో ఆ షేప్లో మనకు డిఫెక్ట్ అనేది ఇమేజ్ ఓరియంటెడ్ రిప్రజెంటేషన్స్లో కనిపిస్తూ ఉంటుంది అనమాట. సో దట్ మనం డిఫెక్ట్ యొక్క షేప్ని కూడా కనుక్కోగలం అనమాట ఇన్ మ్యాగ్నెటిక్ పార్టికల్ టెస్టింగ్స్. And same concluding magnetic particle testing, we cannot do the testings we cannot do the testings of all the components. We can do the testings only a component which can be magnetized or which can be attracted to a magnet. And what are the type of defects that we can be identified or be detected in magnetic particle testing is hidden defects and volumetric defects as well. So volumetric defects is nothing but, as I said earlier, we can see the shape of the defect and the size and the length of the defects. So it is called volumetric defects, and the results are temporary. Why I'm saying the results are temporary is we cannot see the results after being tested. Hence, all these particles, see in previous slide, here there is particles remaining upon the component. Actually, these particle has to be removed very soon after being inspected. Once it is being removed, we can't say or we can't conclude there is a particular type of defects. Hence, the results are temporary. We need to take an or we need to capture image of particular defect. Then only we can record or we can remain the particular type of defect and the image of defect. And what is the range of testings is we can test only the surface and subsurface defects in magnetic particle testing or by using magnetic particle testing, that is only up to 6 mm. If the component is having 10 mm length, we can only inspect 2 to 6 mm of length. This is the only inspected area, inspected zone in magnetic particle inspection. We can't inspect the entire component, or we can't inspect the defects which are having higher thickness than 6 meters. Okay, that's what in magnetic particle testing the range of inspection is only 6 mm. If the defect is laying after 6 mm or higher than 6 mm, we can't inspect those type of defects by using magnetic particle testing. Okay, and coming to next type of testing, the very important testing and my personal favorite type of testing is ultrasonic inspection, in which we are going to use ultrasonic sound waves onto the component, or by using these ultrasonic sound waves we are going to induce or we are going to inspect whether there is any flaw or defect in a component. So ultrasonic testing, UT uses the transmission of high frequency sound waves into a material to detect imperfections within the material or changes in material properties. Like we will have some particular type of probes called transducers, which converts one form of energy into another form of energy. By giving the electrical energy to that particular type of probe, it converts that electrical energy into the ultrasonic energy, and starts passing or directing into the component. Here you can see a blue colored white device on the screen here upon the component, right? And this component is called probe, through which we are going to send the high frequency of ultrasonic sound waves onto the component. Okay, so this high frequency of component starts passing into the component and reflected back after the end has been reached, and the reflection will also be received by these transmitter device or probe. And we can't see or we can't visualize all these things happening inside the material, isn't it? So we are going to have an display, CRT display of cathode ray tube, to mention all the deviations and perfections and imperfections of component by using these type of echoes. See here you can see two echoes in first image and three echoes in second image. What is the difference between these two echoes and the three echoes is the process of being ultrasonic sound waves passing from the end, from the starting to the end position, and the end position to the starting position is being imaged or being digitalized into this image. This first echo is going to denote or indicate the passage of the ultrasonic sound waves from the device to the component, and the second echo is going to imply that the ultrasonic sound waves is being reflected from the end of the component back to the initial area, from starting point to ending point. And by knowing the length between this first echo to second echo, we can also know the thickness of the component. It's not just a method to know whether there is a defects inside or not. It is also used to know the thickness, or it is also can be used as measuring device for complicated surfaces, or the surface or a components which cannot be measured its thickness through using normal scales or normal tapes as well. See, coming to the second part here at the right side, you can see a small black colored line inside the component, isn't it? So this small colored line is affecting, or making the sound waves reflected from its surface. The sound waves is not going to reach up to the end point. From the starting to end point, the sound waves is not going to reach due to the imperfections or mismatch of the component here. So as the sound waves is getting back from this short area, the echo inside the two echoes, actually these first echo and the last echo is considered as major echoes, called initial echo and backward echo. If you can see any disturbances or any echoes in between the first two echoes, like initial echo and backward echo, this echo can be said as a denotation, or can be called as indication of defect. Okay, so if I have a sequencer here, I'm sending a ultrasonic sound waves from here to here, and this is my goal and ending point. Here the ultrasonic sound waves will pass up to the end point and will definitely reach to the ending position. And in this case, the initial echo which passes and the backward echo which reflects only will be noted in this area. And coming to here, I have another material being inclusion here. So it will not pass until the end. It will just reflected from the surface and will show notification, or shown an echo which is reaching earlier than the surface. And the most commonly used ultrasonic testing is called pulse echo testing method. The pulse is nothing but pulse the indication of these echoes is nothing but pulse echo testing, wherein sound is introduced into the object and reflections like echoes are returned to the receiver from the internal imperfections or from the geometrical surface of the part. As I said earlier, as the ultrasonic sound wave is getting passed into the component, it will not pass after the component. If there is any air gap, it will just reflects back. In the same way, here also the defect is also one of the type of air gap, isn't it? So so the ultrasonic sound waves can be reflected from air gaps also. In clear cut vision, see, I have a component here, a cylindrical type of component, and I have a display here. So I'm going to I'm going to induce, or I'm going to direct the ultrasonic sound waves onto the component, and this is the starting point and this is the ending point. Just assume it has height of, or a thickness of 200 mm. Okay, the starting point is 0 and the ending point is 200 mm. So as indication of the ultrasonic sound waves is getting processed or directed into the component, there will be an echo at starting part of the screen, and this echo is going to indicate that the ultrasonic sound waves have been transmitted into the material. See, the sound is transmitted into the material to be tested. Once the sound waves started traveling into the component, this echo will be appeared upon the CRT screen. Once, if the sound waves get reflecting back, definitely You will also visual, or you can also see another echo at particular point, or at the particular point on the screen, and this point indicates the thickness of the component. Here the first echo and second echo, it will the first echo will be at 0 and the second echo will be at 200 mm. Why? Because the thickness of the component is 200 mm. It starts from 0, which indicates the initial echo, and reflects from 200 mm, which indicates the backward echo. If there is any gap, or if there is any hole inside the component, if I place the probe upon the component, if the cursor, just assume the cursor is a defect, then the ultrasonic sound waves will pass onto the component, onto the cursor, and will not pass beyond the cursor. It will just reflect back from the cursor. So I can also see another echo in between these initial echo and backward echo, which represents there is a flaw in between the starting point and ending point of the component, which can be termed as internal flaws or sensitive hidden flaws. Okay. And coming to the conclusions of ultrasonic inspection, the ultrasonic inspection is a type of methodology in which we can detect hidden and sensitive type of defects in a mechanical component. Hidden and sensitive in the sense, already I have said, like hidden defects is nothing but which cannot be seen or visualized through our normal human ear, human eye, is called hidden defects. And sensitive defects is nothing but we can sense a defect, we can sense a defect of 0.1 mm diameter also by using this ultrasonic testing. And type of results is echo form. As we see in previous slide, the results have been visualized in echo forms. So hence it is called, the type of results will be echo or digitalized also. And if we need the results for future purposes, we can save these type of results in a device called Medsonic machines, or fraud detector machines, or digitalizer machines, etc., etc. There are many models in ultrasonic testing. We can use these type of testings not only in mechanical fields, we can also use in medical applications, and also use in construction applications. Okay. In medical applications, to see the baby inside the mother's womb, a type of testing that the doctors has been carried out is called an ultrasonic testing. Okay. The screen will visualize or gives you the visual of a baby inside the mother's womb, isn't it? In the same way, the component, by using the ultrasonic testing on a mechanical component, we can also see whether there is any flaw or any other material incompositions or inclusions inside the component, by using these ultrasonic inspection. And what is the range of this testing, like ultrasonic testing is 6 meters. We can inspect any component up to 6 meters by using ultrasonic inspection. For mentioning, I have just mentioned like 6 meters, but I can say it is infinity. Why? Because no other material will be having the thickness more than 6 meters in a mechanical field. If you can consider aeroplane, it might be the biggest aeroplane might be half kilometer in size, but the thickness of the aeroplane will definitely not cross 6 meters, isn't it? We are going to check the thickness of the component, and we are going to inspect the component by using or measuring the thickness only. So any component having thickness less than 6 meters can be inspected by using a test called ultrasonic testing. There is no limitations in materials to ultrasonic testing. We can induce the ultrasonic sound waves in a human body, we can induce the ultrasonic sound waves in a mechanical body, we can make it pass through glasses and bricks and concrete, anything. Just the thing is, we need to change the velocity and the speed of ultrasonic sound waves in which it can be float or it can be passed easily according to the change of medium or according to varying of a medium. Okay, in ultrasonic sound waves also there are three different types of sounds like audible sound, ultrasonic sound and infrasonic sound. Of those three type of sounds, we have choose only ultrasonic sounds to do these type of testing. Why? Because only ultrasonic sound will have the capacity to get into a component. No other sound can get into a component. For example, I can say, even when I am speaking, there is a sound called audible sound. Okay, of course it is also called a sound, but I can't use these audible type of sound to inspect a component. Why? Because my audible sound will definitely get reflected when it faces a rigid body. See here, if I'm speaking by keeping my hand in front of my mouth, definitely my hand will reflect the sound, isn't it? So if my hand is reflecting the sound, then I can definitely say the sound is not going to be travel through my hand or into my hand. If the sound is not going to travel into my hand, I cannot say or I cannot trace what are the things happening inside my hand, isn't it? In the simple way, the sound of my the audible sound cannot pass into a component in which we cannot see or trace whether there is any defect present in the component or not. Only the ultrasonic sound, which the name itself indicates, ultra means the highest frequency of sound. Highest frequency in the sense, if I shout, it's not called high frequency. The intensity should be higher, not the frequency. The intensity of sound should be higher, then it is called higher frequency. Actually, the ultrasonic sounds, we cannot hear the ultrasonic sounds. The vibrations, actually sound is nothing but a form of vibrations, isn't it? The vibrations in ultrasonic sounds or the ultrasonic type of sounds will create the higher vibrations than the audible or the infrasonic. Okay, hence we are using ultrasonic sounds to inspect a component. And coming to next type of testing, liquid penetrant test. As we know, it is one of the very easiest and simplest method of NDT than any other. Okay, so what is liquid penetrant test? Is a, a type of test or a type of inspection being used by a liquid or a penetrant or a dye upon the component, and it shows a surface cracks or a surface defects, then it is called liquid penetrant inspection. It has many names in industries, called dye penetrant inspection or penetrant testing or dye penetrant testing or DT or PT or LPT, anything. The common terminology or the common process is liquid penetrant testing, which is familiar one. In these liquid penetrant test, we are going to use some different types of chemicals on upon the material surfaces and test the component whether there is any presence of defects on the component or not. So coming to the key points, PT, which is penetrant test, is probably the most widely used NDT method. The test object or a material is coated with a visible or fluorescent dye solution. Dye solution is nothing but, as I said earlier, we are going to use some chemicals to find out the surface defects. We are going to apply these type of chemicals on entire surface of the component, and the excess dye is removed from the surface and the developer is applied. The excess is not removed very soon after application. We need to have some dwell time after applying after applying a penetrant. We need to wait for 5 to 10 minutes of time, and then we need to remove the excess penetrant upon the component. and very soon after removing the excess penetrant, we are going to apply another chemical called developer, which will be white in color. Okay, and the penetrant will be in either red or green or pink in color. The penetrant chemical will be either in red or green or pink in color, and the developer will be in white color. Okay, and the developer acts like a floater and draws penetrant out of the imperfections which are open to the surface. You can see the image here. This is a solid block or a normal component which is in which a crack is present here. Okay, so the once the penetrant is applied upon the surface of the component, the penetrant will flow into the defected zone. Okay, and once applied the developer upon the component after removing the excess penetrant, these developer will be acting as a bloater in the sense highlighting or making sensitive. These type of terms is indicating bloater. Okay, so this white color developer will behave as a bloater and highlighting this particular part of a component, indicating there is a presence of defect in this area. Okay, and with the visible dyes, the vivid colored contrast between the penetrant and developer makes the bleed out easy to see. As I said, the developer is in white color and the penetrant is in red color. There will be definitely the white difference in between two in these colors. Once I have applied an white color layer, the penetrant will be definitely gets dominated upon the white color layer, and this dominated area which is called defected area, and it indicates the presence of defect. And with fluorescent dyes, an ultraviolet lamp is used to make the bleed out fluorescent brightly, thus allowing the imperfections to be seen readily. I forgot to mention LPT is also a two categorized type of testings. Two categories in the sense the LPT is been divided into two different types of testings. One is visible testing and another one is fluorescent testing. Visible testing is nothing but a test that can be done anywhere and anytime. Like I can do it in normal atmospheric conditions and normal weather conditions also. But fluorescent type of testing is to be done in a dark room or a pit room. A dark room in the sense the radiations or the light or any other things or any other properties or any other characteristics which makes imperfections in that particular area is called some contaminants. All these contaminants has to be removed in pit room or a dark room. Okay, and in that particular area these type of fluorescent type of testings can be done. What is the variation between fluorescent type of testing and the visible type of testing is nothing. The process and the terminologies and the procedure of testings will be common in both visible testing and also in fluorescent testing. The thing which differs from visible testing and fluorescent testing is sensitivity. Nothing like the aerospace industries uses fluorescence for having high sensitivity of the defects or visibility of defects, whereas normal mechanical components or normal mechanical fields or industries uses visible inspection. Okay, of course there is no change in process like applying penetrants and types of penetrants, that will be common in everything. But the thing is, the fluorescent testing is going to be happen in a dark room and visible testing is going to be happen in normal room or open surface. That is the major change, nothing more than that. And the fluorescent type of testing uses green colored type of chemical, whereas the visible type of testing uses red colored or pink colored type of chemicals. Okay, getting into detailed, So how what is the procedure or what are the processes of doing liquid penetrant testing is, first of all, this is the block on which we are going to do the inspection of liquid penetrant testing. Okay, so first of all we need to clean this block by using a chemical called cleaner. Why? We can see the block is clean already, but there will be small sized contaminants or dust particles existing upon the component. Okay, so we need to make sure that the component is free from dust or free from contaminants. Why? Why to do these type of testings this much strictly is, if there is any dust particles at this defected area. See here in the second image you can see a crack. If there is a dust particle settling or being present in this defected area, definitely it will not allow the penetrant to pass into the defected area completely. It will just stop the penetrant upon the component only. If the penetrant is not going to pass into the defected zone, we cannot conclude or we cannot see the inspection, we cannot see the defects, which indicates the test is not being carried out properly. Okay, so we need to make sure that the component is free from contaminants and free from dust particles, and the chemical that you are going to use to clean the component is called cleaner. You cannot clean the component by using normal water. Okay, but because water may also cause corrosion to the component, hence we are not going to use a water. We are going to use cleaner type of chemical which is non-toxic in the sense it will not cause any harm to the components. Okay, and once after cleaning the component by using a cleaner, of course one thing is cleaner will be colorless, there will be no color to the cleaner. Okay, it will be colorless as transparency. And after cleaning the component and making sure that it is free from the contaminants, apply the penetrant upon the component. Here see, the red colored penetrant has been applied upon the surface of the component, and after applying the penetrant upon the component, as I said, we have to wait for 5 to 10 minutes of time. We have to give 5 to 10 minutes of dwell time to support or to get the penetrant into the defected area. Why? Because the defected area definitely will not be visually or visual to our normal eye. If it is visual through our normal eye, we can conclude that it is defected and we need not to undergo a process called liquid penetrant testing. Okay, so so as I said earlier, we definitely need to do these type of testings to find the hidden and surface defects which cannot be calculated or which cannot be inspected through our normal eyes. If our normal eyes is not going to see this type of defects, then you can understand how small or how thin it is. So these thin type of cracks or these thin type of defects needs much time to allow these type of penetrants or liquids to get into the cracked area or defected area, isn't it? For example, if I have 10 liters of water and I need to pass from one beaker to another beaker, if I'm going to use uh, a higher diameter, definitely it will be faster to carry or faster to travel from one beaker to another beaker. If I'm going to use a tube, definitely it will be taking higher time than when comparing to a process of using a pipe. What is the difference between pipe and tube, right? The pipe will be having higher diameter and higher volume will be transferred easily, but when comparing to tube, it will be having smaller diameter and small volume can be travel at a time, isn't it? So this is what here we have to consider it as a tube. Okay, and after giving the proper time, we need to clean the component. Why? Because the entire part is not being defected. The defected part will already sucks the penetrant into the particular zone. Okay, and rest of the zone has to be cleaned properly and thoroughly. See here, as it is, only the penetrant is present in defective zone. No other surface is showing or having the penetrant upon it or on the surface. This is the way that you should clean the component, and especially mentioning the cleaning should not be done through any cloth. It has to be done only by using lint-free cloth. Okay, what is the difference between normal cloth and lint-free cloth is, um, if you put a tissue cloth upon a water, definitely the tissue will sucks or sucks back the water, and in these type of testings you should not use these type of papers or cloths. Okay, but lint-free cloth is a cloth which does not sucks or which does not have any special attracting properties of liquid. These type of cloths are called lint-free cloths. Okay, maximum industries just uses cotton cloths only. Okay, no special type of cloths will be gotten by, because these liquid penetrant testing is one of the cheapest and simplest form of testings. If you are going to buy some special type of cloths, it will be adding some financial fruits on the inspection. That's why they prefer normal cotton cloths to inspect these type of or to do these type of inspections. Okay, and after removing the excess penetrant on the surfaces, you need to apply the developer upon the component, which is white in color. Okay, the white in color developer has been applied upon the component in the fifth image, and see the sixth image. The penetrant which is present inside the defect here is going to be visualized upon the white colored developer in this sixth image, which indicates the presence of defect here. If the surface is remaining still white, you can conclude that there is no defect in the compound. But here there is red color crack or red colored penetrant which seen upon the surface, so we need to conclude that the component is having a crack or a defect in it. So um, the thing, from first, okay, we need to clean the component thoroughly and make sure it is free from the contaminants, and need to apply the penetrant upon the component, and after 5 to 10 minutes of dwell time you need to remove the excess penetrant from the surface, and then apply the developer, and then after applying the developer it will shows the defect and the affected zone. Okay, and once after seeing these defects, you need to clean the surface again. Why? Because as we discussed, all the type of penetrant or developer or cleaner, they are chemicals. They should not be remain, or they should not be rest on the surface of the component for a long time. If it rests for a long time, definitely it will affect the component, which may causes a corrosion or corroded surface, or affect the surface area. So we need to make sure after the inspection has been completed, you need to clean the component or the surface of the component thoroughly. And you can ask, as I said, we are using green color, red color, and pink color penetrant. Why not other colors? Why? Because only these colors will be having higher wavelength and power of attraction in red will be higher. For example, if you see if you see 100 members classroom, if one of them is wearing a dark red color shirt, definitely your eyes will get attracted to that dark red colored shirt. Why? Because it's a nature of red color. It have a higher wavelength and higher attraction power. In order, uh, of course, parallelly, pink also, dark pink also will be equally attracted, and will be having higher wavelength. We are using pink color and dark red color as a colors of penetrant in liquid penetrant testing. And why green? Green, of course, green is not higher in wavelength or highly attractive when compared to red and pink, but I have already said that green color penetrant is going to be used only in fluorescent type of testings. Okay, fluorescent type of testings in the sense, in the testings we are going to use ultraviolet light. These ultraviolet light will definitely make the green color light much sensitive and much brighter. No need of red color or any pink color. The fluorescent type of testings will be using green color penetrant, and visible type of testing will be using red color penetrant and pink color penetrants. And I just said we have to apply the penetrant, or we have to apply the developer, etc., etc. How how to apply? Is it manually, or is it by floating the penetrant upon the component? No. The applications also has some predefined processes or predefined conditions. How should we apply, or what is the way to apply the penetrant properly upon the component? We can apply the penetrant however we want, but the, to make sure the process has been done perfectly and efficiently, we have to make sure it has been applied in an efficient manner. Okay, so as it is again the 6 steps. The first step is cleaning the component by using a cleaner which is no color, and secondly, apply the penetrant. See, the application of the penetrant will be having three different varieties. Like we can you can apply the penetrant by spraying, and by brushing, and last one by dipping. Okay, you can apply the component you can apply the penetrant on the component by brushing the penetrant on the component, or by spraying the penetrant on the component, or by dipping the component in the penetrant. These varies according to the size and component physical parameters. We cannot dip a huge or a large content components by in a beaker, so we can press these type of components. Okay, and while you are spraying, you should make sure that the direction of spraying should only in one direction. Either it might be right to left, or right to left, or left to right, not in both directions. Okay, uh, by applying the penetrant in both directions, it causes some uncomfortable thing to get sucked into the components. If the penetrant is not getting sucked into the defects properly, then you cannot see the defects after applying the developer. If you are not going to see the defects after applying developer, the entire process will be wasted. There will be no use of doing all these types of tests. So you need to make sure the application of the penetrate on the component is happened very clearly and thoroughly. Okay, and after applying the penetrant, you have to wait for 5 to 10 minutes, and in these 5 to 10 minutes the component area, the defect area in the component will suck those penetrant into them. And after applying developer, see, there is a white color layered surface formed upon the material surface, and if you can see anything red here, then it is called a defect. Okay, and what type of defects that you can identify, or what type of defects that you can inspect in liquid penetrant testing is open surface defects and surface defects. Why I mentioned open surface defects is, see here, if there is no connectivity or no flowability from the surface to this part, the penetrant will definitely not flow upon to the end part. Okay, if there is a small hole inside the component, there is no, we can say there is no way to the penetrant to pass into the hole. If the penetrant is not going to pass into the hole, definitely it is not going to be visualized or inspected by our developer. So the type of defects that you can inspect in liquid penetrant test is open surface defects only, in which it will be having the connectivity or the flowability of penetrant to get into the defects. Okay, and what type of results that you can get is temporary results. See here, you have done all those steps, isn't it? Very soon after seeing the particular type of defect here, you need to record it in a paper, or you need to have in photographs of this particular defect, and very soon after making record you need to clean the surface. Once after cleaning the surface you will not see the defect again, hence it is called temporary results. Okay, it's not permanent results as in radiographic testing. Even in ultrasound testing you can save the results, but in in liquid penetrating testing you cannot save the results. Okay, and what is the range of testing is only 2 mm. That's why I said it as surface defects can be identified or detected in liquid penetrant test. No other types of defects can be identified or traced in liquid penetrant test. Okay, and coming back and coming to visual inspection, VT is, that is visible testing, is probably the oldest and common method of NDT, having numerous industrial and commercial applications. As we know, the scaling or measuring the particular area, or measuring the particular size or dimension in physical properties, we need to have visual inspection, which is widely using before the times of NDT. Not only in NDT, it's being used before times of NDT as well. Examiner follows procedures ranging from simple to very complex, some of which involves comparison of workmanship samples with production arts as well. See here, why I'm mentioning a simple to very complex is, see, if I'm manufacturing a scale of 15 centimeters, I need to measure this, whether the readings in the scale is right or not by using another scale. That's much simple. And measuring a scale by using another scale is very simple. There is no need to put your mind and concentration upon strictly on that particular type of measurement. But when it comes to very complex, you need to measure whether, for example, I can say a turbine blade. The inclination of turbine blade at its starting to ending should be in the same inclined direction. If the direction of the inclination has been changed, then then the application of the turbine or a propeller will not be happening, or will not be efficient to its input, or to its output efficiently, isn't it? So the inclination of direction, the measuring the inclination of direction from starting point to the ending point of the turbine is not that much easy. It's very complex, isn't it? So measuring a scale is simple, measuring a turbine inclination is complex. That's all. These visual inspection can be done from simplest type of testings to very complex types of testings. And here I need to mention that these visual inspections is also in two categories called specific inspections and non-specific inspections. Specific inspections has been carried out by taking some references which will be globally same. In the sense, if I'm going to use a bolt, if I'm going to manufacture a bolt and a nut, I will take some references from ASNT or ASME standards. It will be common in India, in abroad, and anywhere in the world. It is called specific type of inspections, which will be carried out commonly in all industries. But when it comes to non-specific inspections, it is related to the particular employee. He can also use a stick, or his hand, or any type of rod for his convenience, not reference, not according to any particular references. For his convenience, he can take any measuring devices like his hand or a stick or any rod that is flexible for him. This type of inspections is called non-specific inspections, which has no records or no proper instructions to be carried out. Okay, but when comparing to specific type of inspections, he has to get references which has to be same globally, not only in his industries or in his surroundings. It has to be common global wide, like how to say, Of course, charger of a phone will be here. I have a C type cable. I can keep any type of C cable in this slot. It will be working. That is called specific, which is carried out through references. If I am taking it through my convenience, I cannot place another charger in this sort, isn't it? So it is called non-specific inspections. The thing which can be common and entirely same for other industries and other countries also is called specific type of inspections. Okay, and visual techniques are used with all other NDT methods. As I said earlier, if you need to know the length, know the size, shape, etc., of the defect being inspected either in radiographic inspection or ultrasonic inspection or magnetic particle inspection or lipid inspection, you need to note and measure the size of the defects. Then this process of measuring of the particular defect is also called visual inspection or visual testing. In this way, the visual testing is being involved in all types of entity methods. Okay, there is no particular device, only these device can do visual inspection. There is no such type of devices. You can use magnets, magnetoscopes, periscopes, scales, and rods and tapes, whatever you need. Okay, any measuring device which shows the perfect reading without error. I especially mention the device should not be have any error. Okay, if it is error, you need to calculate the error and make to be noticed in tolerance limits. Okay, and of course, in NDT there are many bodies and many certifying bodies governing these NDT certifications. In India, it is called ISN. The full form of ISN is Indian Society of Non-Destructive Testing, but it is valid only in India. In the same way, there are three important governing bodies of NDT. I mentioned here two bodies like American Society of Non-Destruction Testing (ASNT) and Canadian Institute of Non-Destructive Evaluation (CINDE). These two are majorly used governing bodies of NDT. Why I am mentioning only these two is if a person have a certification body on ASNT or CINDE, it can be valid on entire world basis, not only in particular America or particular Canada. It can be valid worldwide wise. If I'm a person who is having an ASNT certification of NDT, I can take it to anywhere in the world and it will be valid. Okay, and if it is ASISNE, it will be valid only in India. And there is another certification also called PCN certification, called Provisional Certification of Non-Destructive Testing. It is being used in British world and in German countries. What is the difference between these governing bodies is the margin or the limit range of defects will be variated here. Okay, nothing else will be varied. And NDT personal qualification and certification. As new NDT methods and new techniques were invented, developed, and applied, the need of trained technicians grew rapidly. Yes or no? As I said in earlier, we are getting multiple new companies and new industries getting into the market. If there is a new car company getting into the market, the car has to be inspected. The inspection has to be done in NDT. So to do NDT inspection, they need crew to do NDT inspections. They need a crew of people who are certified NDT bodies. So as the companies are getting numerously or getting launched, they all companies needs NDT. And here I specially mentioned NDT is not only for these type of component. It's nowhere mentioned NDT can be done only for these type of components or only for that type of components. Any type of component, the NDT will be common. If I'm going to inspect in a shaft, the NDT will be common. If I'm going to inspect an aerospace component, the NDT will be common. If I'm going to inspect an concrete in construction area, the NDT will be common. Anywhere, the process and the procedure and the terminology and the conditions you applied on NDT will be common. What the difference is, the only component is getting differed, not the type of test or the type of testing carried out is not going to differ from one area to another. Okay, and it soon became apparent that NDT technicians and engineers with suitable training and qualifications were in very short supply. In current industries, there are no much people or much supply of NDT inspectors. Okay, they are waiting or they are giving contract jobs and they are hiring many people, and still there is lack of person who can do NDT. Why is the reason there are a lack of people in NDT is there were no accredited colleges teaching NDT. Not only in Andhra Pradesh or not only in Telangana, no other state is teaching NDT, even though it is very much important and very much upgrading technology or upgrading type of inspection, and of course it is very useful and very much needed. I cannot say it is useful, it is mandatory, it has to be done, it is compulsory, not useful. If it is not useful also, it has to be done, it is mandatory type of testings. Even though it is mandatory, no other institutes or no other colleges is teaching or providing laboratories on NDT. That's why many people has no awareness on this type of field called NDT, and there are many job opportunities and many vacancies on these NDT fields, but very few people know. Once you get into the field, you can also earn lot. Not only a software engineer can earn lot, mechanical engineer can also earn a lot. The only thing is the mechanical engineer is in a mental state that only design will be having certifications, only design will get me a job. If I am not having a design, I will go to another field called software field or IT field. There is also another level of certifications in mechanical field also. To be frank, there are more than 30 fields in mechanical industries. Only few people will know there are 30 fields. The rapidly or well-known familiar fields are like castings, productions, and designs, and CNC. People know only these type of fields, but actually there are more than 30 fields in mechanical field also. Very few people know. One who know is earning lot and lot and lot and lot, but one who don't know is just changing his career to another field and quitting as a mechanical engineer, which is very much very unfair actually. The only thing is I have to be get aware of what are the fields in NDT. Okay, the NDT, the NDT course is very much basic and the best choice of any mechanical engineer who wants his career to be designed in mechanical core. Okay, and how VIDAL NDT, our organization, is being implemented in NDT is a person who is getting a course in our institute will be having 100% placement opportunity. Either it might be in the country or in abroad as well. Every student, we will be showing a placement for every student who are getting joined or getting a course and certification in our institute. The course content designed by industrial experts covering very important topics. Here in our Vidal NDT Institute, we are not going to follow any authorized textbook or any college printed material. Here we have some meetings and we have some conferences and we have many more discussions to know what is much efficient to the student and what is useful to the student and what a student will be benefited if he know these things, and what will be useless to the student. We are just avoiding all those parts, and we are just teaching, or we are making access to the area where a student can make he himself sharpen in mechanical core, and make his and design his career bright as a mechanical engineer. Okay, and state of art training sessions will be done by using theoretical and practical session as per the industry standards in industry aspects. Like we have laboratory in our own institute, we need not to go to anywhere to show how LPT is going to be carried out, how UT is going to be carried out, how RT is going to be carried out. All equipments are being in our laboratory, are being furnished in our laboratory. We can do any type of NDT methods in our laboratory at any time the student wants. Okay, and every subject will have industrial visits. If you are going to do LPT, we will take you to an industry or where LPT is being existed already, and we will be explaining how LPT is evolved in inspecting a particular type of material. For example, if a company is undertaking an UT, if a person is getting traveled in our institute, and there is a topic discussed for the particular individual, then he will be going to the industry with one of our faculty, and will be explain what are the things happening by using UT in the industry, so that he will be having some industrial idea, so that he can grow industry. Not only classroom lessons or PPT presentations can help a student to design his career. Also, his industrial visits will make sure how the industry is going to be, how an industry will provide a job opportunity to him. If industry gives a job, how he should be flourished in that particular area has to be is being very much thoughtful and very much useful in VIDAL NDT. Unlimited career guidance for students for the future careers and advanced certifications and job opportunities. As I said, job opportunities is 100% for any person who is going to take a course in our institute will be having a job at the time of at the end of the course. There is no doubt. And career guidance in the sense, if the person is not very much comfortable for getting only level 3 of NDT, he can also go for boiler inspector, or he can also go in for auditing, or he can also go for painting inspector. The thing which is comfortable for him can be discussed and designed according to his concentration and his interest. And advanced certifications, like there is no particular stop for these certification courses. And when coming to certification courses, there are many certification for courses for software like Java, Python, C, C++, etc., 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 blah 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 blah. But when it comes to mechanical field, if I ask a passed out mechanical guy what are the add-on certifications in mechanical, he will say one AutoCAD, two what is that, ANSYS, and three CATIA, four SolidWorks, and five blah 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 blah. All this comes under only one certification called design. Okay, all the the only certification a mechanical engineer is knowing is design, but actually there are more than 60 plus certifications in mechanical field also. One among them was NDT, and after NDT there are many more certifications yet to be done. What is the use of doing these certifications is, you will be having special interest in an industry. The person who has special priority in industry will be paid specially, in the sense the salary will be increased. And digital library will be having in our institute, and worldwide valid certification. As we are providing ASNT certificate, it will be valid for entire world. You can do the course in VIDAL NDT, and you can do the job in America also. And yes, on-site training in petrochemical, refinery, oil and gas industries, and power plants, or any mechanical core industries. We will also provide in proper industrial visits or industrial expo and internships also, if the individual is interested. And here you can see that many courses that industry that Vidal entity has been involved, and the red color was the duration of the particular courses. Okay, so the first one is PG Industrial Engineering Management, in which involves many type of individual courses like NDT, quality, solar, fire and safety, etc., etc., etc. Altogether called PG Industrial Engineering Management, which will be done for 1 year. And non-district testing, as I said, NDT is very much important, and there are many field opportunities in NDT. It has 30 days. One individual has to spend 30 working days of his life to get NDT certified, and quality assurance and quality control has 15 working days. And solar, as you know, the future is all depending upon solar. The solar technology is also one of the most innovative and technology, and which is going to be evergreen within very few years. We are also concentrating on that area. And finally, it's fire and safety. Many technologies may come and go, many industries may come and go, and all the companies and all technologies must and should have follow safety norms and safety precautions, and which is taught in fire and safety. Okay, not only in mechanical, even in malls and supermarkets, there are fire exhausters and fire preventers. All these things can be learned and can be done in fire and safety. So in a mall, I cannot just go and keep some mud there, and I can certify a mall that uh, it is being a very safe place, that any person can get into a mall. But a fire safety officer, who is the person who can authorize a mall whether it is a safe place or not to people to visit a particular type of mall. Okay, and finally, here we are available. The Vidal NDT Institutes is available in Hyderabad, Amirpet, Vijayawada, Ben Circle, Kakinada, Banuguri Junction. These are the familiar places in that particular cities. We are available, and our institutes are available. Especially mentioning, we have admin office in Kakinada. If you are interested to take a course, uh, you need to go for Hyderabad office or Vijayawada office. Our office doors are always open to you to get a demonstration or seminar of what type of testings or what type of career that you are going to be choosed, or you are going to be preferred in future aspects. We are always welcome, and also you can always free to call to our number 888 608 2111. You can call to this number at any time, and you can ask your queries, and you can show your interest in joining in any of our mentioned courses, so that we will be saying what are the things for the further processes to be happen, and how how the career can be grown in mechanical fields as well. Okay, here we Vidal entity is acting as a bridge in between the mechanical engineers and the mechanical fields. It's not very much easy for an BTech passed out student to get into a mechanical industry. It's very tough. If we go with his individual interest, definitely he's going to work as a normal employee or normal worker in that particular company. But it is not enough for an graduate person to earn as he needs. it is very much difficult to be a technician or to be an technical assistant or to be an authorized person. To get an authorized position or to get an authorized place in an industry, you have to be certified in some other type of add-on certifications in mechanical industries, also called NDT certifications, or welding certifications, AWS certifications, or auditing certifications, boiler inspector certifications, etc., etc. There are many type of certifications can be done, and to know what all other things to make to get an NDT level 2 certified will be discussed later. If you need, you can call to the number which is visible on the screen here in red color things. And for all the participants who participated in these NDT webinar will be getting participant certificates from Vikas. So I must thankful Sri Srinivas Rao Garu, the HOD Mechanical Department, for providing the valuable opportunity for VIDAL NDT and our organization for making this happen, and to interact with all of you guys. And I thankful the Department of Mechanical, the management team of Vikas, and especially mentioning Srinivas Rao sir. I thank you very much, sir. Thank you, and signing off. Have a good day.
Good afternoon, everyone. I am Potom Srinivas Rao, HOD Mechanical Engineering Department, Vikas College of Engineering, Nonna. On Good afternoon, everyone.
प्लेस है ना.
I am Potom Srinivas Rao, HOD Mechanical Engineering Department, Vikas College of Engineering, Nonna. On behalf of management and staff of our college, I am very happy, grateful and thankful for today's resource person, Mr. Bharat Kumar, MD, VIDAL NDT, Vijayawada, for his extraordinary speech on the recent developments in NDT, non-destructive testing. Sir, I am very thankful to you, sir, for your valuable and recent developments you have given to us on NDT. I am very happy, grateful and thankful to all my colleagues of this webinar. Convener Mr. M.V.U. Bhaskar Rao, co-convener Mr. T. Mastanaya, and coordinators Venu, B. Naveen Kumar, G. Vijay Kumar and Ajit Benson, and all others who contributed directly and indirectly for the grand success of this webinar. I also like to mention once again to our management, grateful and thankful to our chairman sir Sri N. Narsireddy Garu and Vice Chairman Sir Sri N. Sachiran Reddy Garu and Principal Dr. B. Ramana Garu for their cooperation and acceptance to conduct this seminar, this webinar. And finally, I would like to say thank you very much from my bottom of heart to all the participants for this webinar from all over India who are online at present and made this webinar grand success, and I am very much thankful to them. Thank you very much for all. Thank you very much once again. for making this webinar a grand success. Thank you.
Done. Sir, stop streaming kotna. Stop streaming. Kotna.